So let's take a look at that next one right over here. So while this one might look a little bit freaky at first, we need to do two things. One, like I said, split things into sine and cosine. Makes our life easier, right? In this previous one, we had to change the tangent into sine over cosine, and in the secant, we turned it into 1 over cosine. Well, we're going to do the same kind of thing here with the cotangent, and we're going to take a look at the fact that like this 1 minus cos squared, well, that's really just this identity in disguise, right? So we know that's equal to a sine squared. So most likely we're going to use that, but in order to kind of, make sure, we might leave it, we might change it, know that we can change it back. Since it's easier to write sine squared, I'm going to start by doing that. So we're going to change this one to be sine squared x. And we're going to multiply by 1 plus, now cotangent is the reciprocal of tangent, so that means it's going to be cos squared over sine squared instead of the opposite there. Okay. Now, oops, I forgot to put in my little line. We'll make it a little bit angled here. It's equal to 1. Okay, now, when we do this, of course, similar thing, whenever you get fractions, you're pretty much always going to need to combine them into a single fraction, because otherwise there's not much else we can do. Well, you know what? That's not true. Instead of doing that, we could also just put this in. So maybe I'll show you both ways to do it, okay? First, let's do it the initial way that I thought of, which is just get rid of this 2 fractions and turn it into a single fraction. So I need to rewrite that 1 as being a sine squared over sine squared. And then, of course, I'm adding that to a cos squared over a sine squared. And I'm multiplying this whole thing here just by sine squared x. Okay, so now, if you look over here, we can, of course, see, zoom out a little bit, be easier to see it, I think. Then we can see here that we're going to now combine them, and we're going to get that sine squared plus cos squared. So that's just going to be 1 over our new denominator, which is sine squared. And we're going to be multiplying that by sine squared x. And of course, sine squared x over sine squared x is going to cancel, and we're going to just be able to show that 1 is equal to 1. Okay? Now, I did tell you that I actually saw a different way we could do it right here. So let's pull that aside and do that. So sine squared x multiplied by 1 plus the cosine squared of x over the sine squared of x. And what I had said is that we could also just distribute this in, right? And sometimes that's helpful, sometimes it isn't. Really, the thing to remember here is that there's always more than one way to do it, and there isn't a right way. There's usually multiple right ways. Okay, so if we distribute that in, I'm going to get sine squared x times 1, which is just sine squared. And over here, I'm going to get sine squared x cos squared x over sine squared x. And hopefully there you can kind of see it. Those sine squared x's are going to cancel. I'm going to be left with sine squared x plus cos squared x, which of course we know is just 1. And of course it was going to be equal to 1. That's what we were trying to prove. So either way we do this, we're going to prove the same thing, that it's equal to 1. So if you see something that looks a little more complicated, don't panic. Take your first steps, right? Split it up into sines and cosines if you can. Usually helpful for most of us, which means split your tangents and cotangents, your secants, your cosecants. And then the second thing is look for that identity. Anywhere you can see a 1, you could replace it with a sine squared plus cos squared. If you see a sine squared, you could replace it with 1 minus cos squared, etc. So you want to always be looking for those because, of course, making things equal to 1 really helps. So we should do that whenever we can. All right, guys, that's going to do it for this one. If you found this helpful, don't forget to like and subscribe. Tell your friends about us. We also offer tutoring services, so feel free to reach out to us. Look for Momentum for Life, and let's keep this momentum going.